Hello, everyone. How are we doing? It's been a long day already. My hair's just going crazy. All the weather, all the heat. Anyways, if you're in the chat, feel free to say hi. I'm trying a new strategy right now. I'm labeling these office hours what we're doing, so I'm not using the date anymore. So, I guess I'm more informative than... Oh, I'm going to UT Print is what I'm doing. More informative than that. Anyways, need to wake up. Get more caffeine. We all need some caffeine. But we're going to do Chapter 5, Part 1 homework, and then talk about the other portions. I think people got a lot of views on the data analytics. So I was like, oh, maybe if I put what we're doing in the video title, people will be like, ooh, he's doing Chapter 5, Part 1. So we're loading up my Pearson right now, and you can always jump into these office hours anytime you're watching this. You just jump in, you say, hey, let's do this. And although this video might be named Chapter 5, Part 1, you just hop in and you say, hey, Brian, I need help with this. You can also use the search on the YouTube to answer questions. If you go to the search menu, you search, and you find a question. Let's do Chapter 5, Part 1. Okay, over here, got that loaded. And let's load in a Word document. Okay. So many Word documents over here. So, need more caffeine. I got a caffeine addiction. It's bad. Okay, with Brian's caffeine addiction out of the way, let's close out of our tab. And then let's go over here to my Pearson, and let's do it. Okay, if you're watching this video, I like to do, I guess, learn by teaching or learn by doing. And let's put right here, 243, Chapter 5, or Statute 1, Chapter 5, homework. Part 1, question 1. So we never directly answer anything immediately. We tell you how to do it so you can learn the concepts. Think about each question as trying to teach you something. What are you trying to learn from this one? Well, we need to learn some notation. As we like to say here.
Notation, brother.
I think it's notation, brother. So what is the deal with notation? Well, we're going to go over here and take a little screenshot of this and know our notation. So if you're taking notes on this, note the notation. So the things to notice right here is the average score on the midterm was this. So the average score on the midterm, we're going to put right here is mu. That is population mean. You could use y-bar if you wanted, but mu is population mean with a standard deviation of sigma. That is standard deviation. Think of standard deviation. And then average is mean, so think mu is mean. And then Arthur's z-score is equal to 2. So you can use the formula that we could say right here, the z-score is equal to the observation minus the mean over the standard deviation. Plug in the numbers and you will get that 2 is equal to, and we're solving for y because we don't know what Arthur scored. Y stands for observation, which would be Arthur's score on the test. Now we know that Arthur is 2 standard deviations above the mean. I'm going to solve an alternative way up here. Since we know the mean is 77, we can literally just go 2 standard deviations above the mean. I think I've done it correctly. Sorry about that. And you can also solve it down here by doing observation minus the mean of 77 divided by the standard deviation of 7. So what you'd get right there, we'll erase, or we'll just hone in on this work. We're going to just focus in on this because this is how you could solve it by using what's written right here. You can take now, sorry, and do 7 times 2. Hey, what's up, DD? Good to see you. We're showing how to solve some problems right now. And use 7 times 2. So if you times both sides by 7 times 7 times 7, you get 14 equals y minus 77. So then you just do plus, nice and colorful, plus 77 plus 77. And that gets you right here, 91 equals 2y. So we kind of did a little over here and then over here. Psychology Today, what is that? Real life question stats? Yeah! What's it about? Let me know. Psychology Today, what's it about? What is it? I don't understand this perfectly. If you can help me understand, it's super helpful. Yeah, I can cover it. Send me a message. I'll take a look at it. Yeah, I'll answer it after class. That's awesome. Dee, thank you so much. Psychology, you know that's my background. I hopefully know some psychology stuff. Send me a message, and I'll take a look at that. Thank you so much. Let's show Dee some points. I don't think I've ever reset your points, DD. So feel free to check those points. But yeah, send me a message on that. I'll do it. Nice. Awesome. Well, that's got the first question. We're doing a little Z-scores right here. Brandon knows a little psychology. I don't know a lot of psychology. Points. There we go. How many? My points are insane. The amount of time I've streamed. You are at 200,000 Mu-Bucks. 200,000 Mu-Bucks. I am at, we'll do question 2 in a second. I'm at 14 million. I'm 100% morbed in. We got Morbius over here.
Let him cook. Let him cook now. Let him cook.
There was points in the class.
Let him cook.
It's morbid. Gotta make the morb better. The morb is, wait, I gotta restart the morb.
Let him cook.
Going off the screen.
Let him cook now.
There we go.
Let him cook. I said, let him cook.
It's morbid time.
Get a shirt. I wish there were something more than just fun, but sadly they're just there for fun and for bonus in the class. So if you're in the class, if you ever do take the Stats 1 class, Mu-Bucks are redeemable 4 points on your final grade. That's what the thing right there when it says 1.3 or 0.74. So that's what that is for right there, for how many Mu-Bucks you get. I had a little protein bar. It had nuts in it, and I'm all trying to not cough. Okay, 743. So there is this thing about the Dunning-Kruger where in people's average claiming to IQ is typically 120. Oh yeah, I believe it. This is an IQ one right here. It's amazing when you ask people like, what is your IQ? Not that he asked people that, but a lot of people are like, oh, I have such a high IQ. And it's like, well, it's kind of weird how the average IQ is 100, but the article talks about statistical misrepresentation. Totally true. So it's statistic and psychology. Ooh, I like this. And if you look right here, people with a Z-score of 2.25. And so what does a Z-score mean? I think DD, you know Z-scores, right? So what does a Z-score mean? Because Z-scores allow us to standardize data. And this is where we can graph it out. I always like to draw the normal curve, the Gaussian curve. There's the Gaussian curve. And when we graph this out right here, we'd go 1, or that's 0 rather, 0. Now I'm off the screen. I think I can't draw down here. Yep, I can't. And then we go 1, 2.5, 2.25. Variance is considered, yeah. Right there. This is the point they're talking about. That is the point. That is the point. So what this means is this individual is 2.25 standard deviations above the mean. So if we say that this is normally distributed with a mean of 100 and a standard deviation of 24, we can start to solve it. Now this is where the mu goes, and this is where the standard deviation goes. So this is mu, and this is standard deviation. And then I'm going to put it above since I can't write below. So you can see we can narrow this down to it has to be between these two numbers. It has to be between. So this is 2 standard deviations. And this is 3 standard deviations. This is 1 and this is 0. And so when you think about it, where would this be when we are at 2.25 standard deviations? Well, we need to take an extra 0.25 standard deviations on it. That's what we're missing from this. So what is an extra times 0.25? Well, you can times that by 24, and you would get equals to 6. So you can just add it right here, and you can see it's 154. So that's where this would be at right there. And just kind of think if it makes sense right there that it's at 154. Does that make sense? You can also just use the formula that the observation is equal to the mean plus the z-score times the standard deviation. So 154 should equal to 100 plus 2.25 times 24. And so you can solve this out. 100 plus 54 equals 154. And so it's important to know what the z-score is. The z-score is how many standard deviations something is above or below the mean. So try drawing these out, draw the normal curve, put your standard deviations, and that's got it. We're rocking and rolling right here. Okay. I did this. I realized now that I did this homework in class with my students. So I'm like, oh, that's probably why a lot of people aren't here. Let's do the next. Okay, let's do it. You ready? Let's do it. All right. Yeah, let's do it slower. You ready? And that's a good indicator if people are learning. I'll throw you some more points right here. Okay, so this is an indicator whether people get it. So what is a z-score? A z-score standardizes data. So when you have a z-score, like if I tell you, like, my height is the z-score of 2, what does that mean? So what does a z-score of 2 mean? The person's height is what? Let's look at the formula for a z-score, but just knowing what a z-score means is important to this question. So, like, what does it mean to have a z-score of 2? You're 2 standard deviations above the mean. And a lot of people say away. That's a very common answer I get first. But you could have a z-score of -2. Because if we say the average height is something like 68 inches tall, then you could have a z-score of -2, which would mean you're 2 standard deviations below, which might be something like that right there. So that'd be 2 standard deviations below. Technically, the standard deviations are a little bit closer, but 2 standard deviations below would be this, and this would be a z-score of -2. So and if you're +2, that means you're 2 standard deviations above the mean. So it'd be 6.2 right there. So that's what z-scores mean. It's how many standard deviations we are above or below the mean. It's above or below. So when we look at this right here, we're given 2 different tests and 2 different distributions. So it's very important to note that we have here the economics, and the economics has a mean, and the economics has a standard deviation. That's a really nice one. And then we are given the one for the math test, and the math has a mean, and the math has a standard deviation. So let's write here, this is what we call the observation for math. This is the mean for math, which is going to be mu sub math. And this is sigma sub math. Does this all make sense right now? So we have what you scored, which is the observed value of your math score. We have the average math score was a 67. Awesome. And then we're going to do the same for the economic score. You scored, I'm going to say you because it's the problem. The mean of you scored, that's the observed economics, the mean of economics, mu economics, and now sigma economics, the standard deviation of economics. So the formula to find a z-score is observation minus mean over standard deviation. That's what the formula is. That is equal to a z-score. The top part is a distance. So when you look at this right here, it's a distance. So this is a distance. And then we take the distance and we put it in terms of standard. People are going to think I'm using the same colors for a reason. I just happenstance did it. And this is standard errors. Standard deviations. So it's distance in terms of standard deviations. How far away is something, the observed value, observed from mean in terms of standard deviations? Well, you would need the mathematical calculations. Because if you look at what we can do right now, so you need the math, you need the numbers, because we can take the observed value 87, and then we can subtract 67, and we get 20, and then we take that difference and divide it by 12, and we get 1.66, meaning this score was 1.66 standard deviations above the mean. We can do the same thing for over here on this data. We can take the observed of 85, subtract 75, which is a difference of 10, and we can divide by 10, and you can see this is only 1 standard deviation above. Does that make sense? So the blue one over there for the economics is a standard deviation of, or a z-score of 1, and you're just looking at this distance right here. It's a distance of 10, so that's a distance of 10. And then you divide by 10, so it's 1 standard deviation above. It would look like this on the curve. If you drew a curve for it, it would look right there, would fall. Where this one over here is a little further over. If you drew the curve, it would be 1, 2, it would be over here-ish, well, a little further. It'd be a little further over on the curve versus the one on the right. So economics, she only has the question, does grading on a curve linearize? What should I assume? It won't change. So grading on a curve doesn't standardize. It actually shifts the data. So a shifting of the data, which is actually part of this chapter, a shifting of the data happens like this. When you do a curve, your data shifts on the number line. So if you have a number line right here, we call this a shift of the data. And you could have the average of the test was like a 70, and you could curve it to 75. We'll pretend this is actually a scale when you divide. But if the average was a 70, you could curve it to a 75, and that's shifting the data by adding a certain amount. So it wouldn't change the shape of the data. Everyone would just get +5 on their grade, changing the center of the data and the min and the max. It changes the center, the min grade, the max grade, all those things if you shift the data. But really good work and really good questions. So on the economics, which is the one where she scored 1 standard deviation above, since she scored 1 standard deviation above the means economics and 1.66 in the math, or 6-7 round, haha, above, she did better on the math exam. There it is. There, we got it. Yeah. It would change the mean, exactly. This one deals with shifting and scaling, so let's put it in the notes. So let's see. I want to see if this tricks you, Didi. You ready? So here's a tricky one that usually catches students. So this one is about a company trying to speed up their process. Let's go. So the first thing the company is going to do is change this from minutes to seconds. So if we change this data from minutes to seconds, what would happen to the original median of the data? So the median of the data right now is 5.1. So if we change that to seconds, what would happen now? What would happen to the median? Well, so this is called scaling. And scaling, exactly, well, multiply, yeah, basically. Scaling is when you multiply, because if you times everything by 60 or 100 or whatever, well, let's pretend we divide by. If you divide by 10, if these are the grades, and you divide by 10, and it went up to like 75, then this would be 7.5, and that would change the center of the data, and it would also change the spread, because now the data is less spread out. If we did it visually, you would see the data be like this and get shrink in towards 7. Does that make sense? So because the original time was like 5 minutes, you would times that by 60 to get like 300 seconds. So now 5 minutes becomes 300 seconds, and there's a new center to the data. The standard deviation gets multiplied by that value. And we can prove this. Give me a second right here. I'll prove it. It's really easy for me to prove these things in R. And there's some really good notes we're going to take here in a second on this. There's really good, we can write down what happens right here. But let's show this in programming. Really easy for me to program these things. Okay. So here we are in R. And let's just take data. And you can just take the numbers 1 through 10. So here is a histogram of the data 1 through 10. Yeah, definitely. Yeah. Well, yeah, no, I love teaching. That's what we do. And if we look at the standard deviation of this data, the standard deviation of it is 3.027. But now let's store data 2, which is the data multiplied by 10. Well, guess what? The standard deviation is going to be 30.27 or 30.2765. Oh, wait a minute. Did I not? Oh, I did data. There we go. There we go right there. So I appreciate it. Now the data is more spread out by a factor of 10. Does that make sense? When you multiply, the data gets more spread out because you're basically stretching the data, and you can see it here if we graph data 2. Notice how data 2 now goes from 0 to 100. Data 1 only went from 0 to 10. This has a bigger spread to it, so it's more spread out. Same thing would happen with the IQR. The original IQR is only 4.5. Meanwhile, the IQR for data 2 is a factor of 10, so it's 45. And you can know these things before clicking because that's what happens. But what happens if we take our original data and we add 100 to it? Now, take a look. There's the new data. Notice, is the data more spread out? Yes or no, Didi? If I add 100, which is what is called shifting like a curve, you're shifting the data over by 100. Is that spreading the data out more? Visually, it looks like this when you shift the data. Is that spreading it out more? Exactly, it is not more spread out. When you divide, you do this to it. You make the values smaller because you're dividing, so that changes the spread of it. It also changes the center. And then if you multiply, the data values get bigger, and everything gets bigger by a factor of what you multiply by. So if we do this and call this data 3, so this is our third data set, if we were to test something like the standard deviation, well, we could do standard deviation of data equals standard deviation of data 3, and the answer is going to be true. We could do things like, is the IQR different? Is the IQR for our original data the same as our new data? And the answer is yes, because IQR is a measure of range. Speaking of, we could do this and check the range, which I think returns the max and the min. And we should get that the range is, wait, it got mad. Range of data 1 is that. Range of data 2 is this. Oh, well, we should do max minus min. Is the min this? Oh, well, the range is the same. We could do max minus min equals. So I wish range just found you the range. It gives you the min and the max. The min and the max change because they're shifted over by that amount. But the range, which is max minus min, you notice right here, the range of the data is 9. So shifting, let's write this note. Shifting does not change spread. Scaling can change everything. And scaling is done by multiplying and dividing. And shifting is adding and subtracting. So shifting does not change spread. Scaling can change everything. So we kind of see that right here. And so when you look at this right here, when you're multiplying, it'll change both these metrics. Oh yeah. Oh, these are really good for the exam. All you do for this first question, since you're scaling the data, for which value does scaling not change the mean? Yeah, for which thing would scaling not change? And it would not change the 0. Is that what you're asking? The answer would be 0 to that. If the data is centered at 0, then scaling would not change it. That is a very good, that DD 1,000 points. That's a very good test question. I see what you're asking. Like, if this is a what value of the mean would not change via scaling? Exactly. So since these are non-zero, we can just multiply by 5.1 and get the new median, because the median would change. And we could multiply by 2.8. And that's good thinking outside the box. And there we go. So you ready? I want you to help me with these next two questions. So now it says we're going to speed up the process, make it 36 seconds quicker. So we are doing what? What mathematical thing are we doing? If we make it 36 seconds quicker, what are we mathematically doing to the data? So it says make it 36 seconds quicker. We are mathematically doing what to the data? Just think the math of it first. We're shifting it, and then what are we adding, subtracting, multiplying, dividing? So we're making it 36 seconds quicker. So is that adding, subtracting, multiplying, dividing? If we do 36, we're subtracting. So what will be the new median? What will be the new median? What will be the new median? This is where the practice comes in. Well, 36 seconds. So it'll be 306 minus 36. Does that make? Yeah. You got it. And then what will be the new IQR? What will be the new? What will be the new IQR? Remember what IQR is. So we're making it 36 seconds quicker. What will be the new IQR? You got it. 5,000 points. It'll be the same. Because it's a measure of spread, and spread is not changed. We took that note earlier that the shifting does not change measures of spread. Great answer. That's the trick. A lot of people are like, wait, why don't you subtract? It's like, because the IQR is the range of the middle 50%. So when you look at like, where's the middle 50%, it might be somewhere in here. And then when you shift it, the spread of it's not changing. So when you subtract 36 from it, it doesn't change how spread out the data is. And IQR, the interquartile range, is a measure of spread. So that's got that one. Good stuff. Good review. Look at this. We get another easy one. Shifting the data by the constant would not change what? So tell me a measure it wouldn't change. And so you don't have the drop downs. That's really good. Shifting data by a constant, like adding or subtracting, choose it. Tell me a statistical value it would not change. You can do that. There's a lot of ways to shift. Yeah, it'd be a big shift. And there's ways to shift or shift scale and curve. Curve's just the general term. Usually curving is done by shifting. It's a general terminology for altering grades. Like when someone says I curved them. It wouldn't change variance. True. Variance is standard deviation squared, which I think standard deviation might be on here. There it is, standard deviation. So variance is standard deviation squared. So yeah, it wouldn't change the variance of the data. True. Good answer. Okay, this one. Ooh, this is one of the ones people get stuck on. We are going to need to draw out the normal model for this. It is so hot on campus today. So hot. Okay. So here's my pro tip for the test. When the test starts, yes. And this is how I would do this question. Yep, here I'll show it and then we'll hop back to it. You want to draw the normal curve. Now the numbers on the normal curve. Oh man. The numbers on the normal curve are, that's good enough. We go 3 standard deviations. I know you're fine. So the first number is 68, then 95, and 99.7. So here is my suggestion to every student when they take the test. You can have scratch paper. When the test starts, write these numbers down. You also are given them on the test, so you really can't get them wrong because you're given these numbers. So look through your test if you can't remember them. And if you want to double check, find a question because you get to see the whole test that has the 68, 95, 99.7. Be careful. You might say 68, 99. No, 68, 95, 99.7. We give you the numbers. Don't get them wrong. Double check with what's on the test. So here we are. These are the numbers you write first. And then I do what's called the inside-outside trick. So, Didi, if 68% is inside, how much is total outside? If 68% is inside, how much is total outside? How much is total? 32. And then we cut it in half because each of these is worth 16. So 68 inside and then 32 outside cut in half is 16. I like to do what's called riding the rails right here. If you were a skateboarder doing some Tony Hawk, then you need to ride this right here and be like, woo! And if you do this, you should hit 100%. 16 plus 68 is 84, plus 16 is 100. So anytime you ride the rails right here, make sure you hit 100%, or you've made the numbers wrong because you've crossed the whole curve. So the next one right here, 95 inside, 5% total outside, because we're just doing the outside, and then live 2.5. Once again, check by adding up, see if you get to 100. Now this is 99.7 inside, and then we would have 0.15 outside, which is half of 0.3, 0.15 on the outside. So there we go. So now we do the big arrow, little arrow trick, and the big arrow, little arrow trick says take the big arrow and subtract, take the little arrow and subtract the big arrow. What we're doing visually is we're saying, here's the big arrow with 25%, and then we want to subtract out this out of it to find the in-between portion right here. So what is that green question mark thing worth right there? How much is that green question mark thing worth? Which is the area between, and we'll write these numbers, between a z-score of -2 and -3. How much is the green area worth right there? So you take the big arrow of this, and you subtract off this amount. So that's how much is below here. Exactly, that's how you do it. Perfect. And that would mean right here is 2.35. We're saying this area right in here is 2.35. Does that make sense what we've drawn? Oops. Well, we'll draw it back here in a second. 2.35. This is already labeled 0.15. So then how much is... So if we have this, take a look at this. And then we cut off this. How much is this new green area worth? How much is this new green area worth right here? So we take big arrow and subtract a little arrow. How much is that new one worth? Because you want to take and subtract off that area right there. You want to subtract off that to only get the remaining yellow area. How much is that area worth? So you can find the big arrow. The big arrow is this, and the small arrow is this. You take big arrow minus small arrow to get the remaining in the middle. So how much do we get? Yep, that's just it. That's all you do. 16 minus 2.5 is 13.5. You can actually do a trick when you get to this. how would you get this area in here? How would you get one of these? We're almost done. How would you get one of those? So take a look at that in the background, and that's the hint. How would you get one of those? We'll think it's 68, right? So if this is 68 total, if you want one of these, not that close. This is 68% total. So look, you can do this right here, or this right here, and together there's 68. Does that make sense? Like together that's 68. Oh well, no, be careful. You're close. Actually, you basically have it. You don't. So you don't have to. I see you're doing big arrow, small arrow. Technically, you can do that. Here, let me give you the big arrow. The big arrow for this one, because I didn't draw it. If you do the big arrow, is this 50%. So try to do the big arrow, small arrow now, and use the big arrow. So now do the big arrow, small arrow. So big arrow, small arrow now. So now you can do it because this would be the big arrow. And then the small arrow would be this. Exactly. 34. And then if you notice, 34 is half of 68. Does that make sense? 34 is half of 68. And yeah, once you get it, and then if you add up these numbers on the bottom, you should get 50%. And then due to the symmetry, you can just go across here and write all the numbers because it's symmetric. So now we've just done this right here. Good to see you. Crazy in the chat. And we're almost done with the homework. Feel free to ask questions if you got it. But we've now done all the numbers under the curve with the percentages between. Last but not least, we can do percentiles, which is area below a point. So this is the 0.15 percentile, the 2.5. We're just doing the area below it. This is the 16th percentile. That's the amount of area below it. 50th percentile, and then you simply add the 34. We're here from Stats 101, University of Tennessee. Learn some stats. So broadcasting worldwide, the University of Tennessee, Knoxville. 97.5. Hope you're having a great day. 99.85. This is the percentile, which means area below the curve. Area below the curve. So now we can use this to solve the question. So let's go and bring up our question. You're like, wow, that was a lot of work, but now we can actually do it. So take a look. This says that the mean is 100, the standard deviation is 12. What do you think the answer is, Crazy or DD? Oh, yeah, we'll do skew next. We'll do skew after this question. We'll do skew right after this. You got it. I'll talk about skew next. I'll do a whole segment on skew. We got just enough time today. Which of these looks correct? Between B or C? Basically, because with you notice B and C, the right mean is at the center, but look at the 68. Which of these is right between B and C? It's C, because 68 is there. So it's definitely going to be this, because 68, 95, 99.7 with the right mean and standard deviation. Great job, Crazy. Hey, Crazy, we got some points here.
Thank you for being here, Crazy. I am Ubot, the class mascot. Keep learning stats.
Oh, man. Good work, Crazy. Learn some stats. Now comes the tough questions. Where would you expect the middle 99.7% of data to be between? Well, you can read the graphic. So where would the middle 99.7% of data be? So you can just look at the graphic. We picked the right one. We drew the curve. We understand what we're seeing. We've got our version of the curve over here with all the numbers. So where's the middle 99.7? Just tell me the two numbers. It gives you the curve. We could draw this out below ours. We could put these numbers. So where's the middle 99.7? So it's saying the middle 90, like when you think about the middle part of the data, it's saying 99.7% of the data is between what 2 points? So it's saying the middle. Like if you did 99.7% of the data would be between point what? If you take a look right here, you see I have 99.7. It's saying the middle 99.7% of data is between a z-score of positive 3, that should be positive 3, and negative 3. So where is the middle 99.7% of data between? Take a look at this curve, and you can use the numbers there. Where would the middle 99.7% of data be? Exactly, 64 and 136. Helps for me to see the numbers. They'll get a little more difficult here in a second. We'll see. Take answer. Okay, so what percent of people have an IQ above nice job, above 124? Notice 124 Yeah, there you go. 124 has a z-score of what? Do you see how 124, it has a z-score of what? So tell me the z-score, which is how many standard deviations it is above the mean. 124 has a z-score of what? Which is how many standard deviations it's above the mean? 2. So what percent of people would be above 124? We can use our little graphic right here. So what percent of people would be above 124? Oh, boards exam? What are you doing boards in? Well, crazy. Thank you for swinging by. Do you want to see what you're doing boards in? We'll wish you good luck right here. You throw some more points. You can always check your points here on the channel. Congrats on your boards. What are you a surgeon? 10th boards. Surgeon? Anesthesiologist? Dermatologist? I want to hear what the boards are in. What are you getting boarded at? Lawyer? Maybe it's like, oh, really? Oh, cool. Well, congrats. Does India have boards, Didi? Oh, cool. Well, welcome. We welcome everyone here. We're happy to help with any statistical questions. Thank you for swinging by, and we wish you well and best of luck on your boards. It's like a 10th grade board thing. Well, oh, cool. Oh, Pirate's here too. Man, we got everybody. What's up? Look, we got Mubot in the chat saying, "What's up, Pirate?" right there. Well, good to see you, Pirate. Thank you, everyone, for swinging by. We're throwing out all those points here. And I think we have it. What percent is it? If you take a look at this graphic, above a z-score of 2 is 2.5% of the data. Pirate, good to see you here, too. So right here, let's go back. And feel free to ask any stats questions. We're going to talk about skew next. This is all the maths. Every bit of math is going to get taught. If you ask me to do like partial differential equations, I'll say, I don't know that. Okay. Between 76 and 88 is between a z-score of -2 and -1. Since we wrote out our cheat sheet, look at this. -2 and -1 are right here. And since we made our cheat sheet, all we have to do is shade the area. And now we know the answer. The answer is 13.5%. We've already done all the work, all the maths. Every bit of maths is done. Yes, you could do that. Hey, nice job, Didi. Subtracting it out right there. Yes. You can mathematically solve it by subtracting the areas and get 13.5. Basically, take out of the middle 95, the middle 68, leaving the. I'll show you. I'm going to draw visually. Great work. Just if people are wondering in the chat what Didi did, they had the middle 95 is between here and here, and this is where -2 is at and +2. And then they subtracted out the middle 68. So that is the middle 95 with the middle is like ketchup mustard right there. We can do a little bit of that if you want. And so we subtract out the middle 68. And then we only want half the area. So this is where Didi said 95 minus 68 divided by 2. The reason you divide by 2 is because there's 2 areas. So you're subtracting out of the middle 95, the middle 68, to obtain just the remainder. Because 95 is the whole area. It would encompass everything. So great work, Didi. That is a great solve for that question. The mean, the mode, the median, all the formulas, I just, we'll do some skew, and I got a little bit of time after that. Above 112. Can someone tell me the z-score for 112 real quick? Notice 112 right here has a z-score of what? So we've already made our cheat sheet. 112 has a z-score of what? That's how many standard deviations something is above the mean. So 112 has a z-score of, you can draw on this if you want, a z-score of 1. It's 1 standard deviation above the mean. Standard deviation is 12. So when you look at this, we have one more question after this, and then we'll head on over. If you just go above here, well, if 68% is inside, that leaves 32 total outside, 16% on either side. We also drew this out earlier, but there should be 16% above 112. Just make sure to check if it says above, below. Very important right there. So that's above 112. I think it does say above 16%. We did it. Last question. And the answer is they're all true, but I'll explain. That was the longest question. And then DD has a question, then Pirate has a question. So we'll do both those questions. Then I got to run to a meeting. We got all the fun. Thank you for joining in today. So a z-score, when you look at the formula, let's just pull the formula up again. We'll talk skew and mean and median and all that. Okay. The formula for the z-score is the observation minus the mean over the standard deviation. So let me ask you this. Oh, A is true. Would it be good to make a 70 on a test? Would that be good? Would a 70 on a test be good, yes or no? Would a 70 on a test be good, yes or no? What do you think? Make a 70. Is that good? You're like, yeah, 70. It depends on the mean. That is the answer right there. It totally good to see you, Dish, right there. If you make a 70 and the average is a 40 and the standard deviation is 10, what would be your z-score? Because the z-score is the observation minus the mean over the standard deviation. So this would mean you are 3 standard deviations above the mean. So you'd go right here and do 40, 50, 60, 70. So you're pretty well above the mean. You'd be very high. And look at this. A z-score tells us how many standard deviations something is away from the mean. How many standard deviations, which is this, something is away from the mean. That's the top part of the equation right here. So is from the mean. That's the top. The observation. This is a value. So we'll try to connect this. A value is away from the mean, and the standard deviation is that. A z-score standardized, that's literally what it does. I'll talk about that next year, Pirate. You got it. We're going to talk about the mean, the standard deviation, and skew coming up here next. So let me explain that. Thank you for the questions. That'll be the next section of this video. A z-score has a mean of 0 and a standard deviation of 1. That is called the standard normal curve, and you can see I was drawing that out right here. I'll highlight that part only. These are all z-scores right here. The mean of 0, that's where you see mu, and then the standard deviation is the unit increase right there. Nice job. DD's helping out in the chart there. We like it. So that's what they do. Is z-score is a measure of how extreme something is, because more standard deviations you are away. So the answer is all of the above. Let's talk about some skewness and stuff. So we got that homework done, and let's talk additional questions right here. I've got I got about 10 minutes. So let's do this. So here we are at the 43 mark. Yeah, so let's talk Stat Tool 1. This is a good review. So skewness means standard deviations and mode. Okay. So the first thing to understand is, let's write it down right here. Skewness is a way to describe shape. So shape is just how is the data spread out. This is what we call a uniform distribution. And this is what we call a normal distribution. We'll label that. Now let's get it data norm. So this is a normal distribution. It might look weird. We'll make a bigger data set. So this is a normal. I need some friends to teach R. I love R. R is great for coding. And I think we can do uniform data uniform. So that'd be like 1 to 100. Uniform data is flat. It looks like this is perfectly uniform. Think one form, uniform. Now, normal data is not uniform, and this is where Pirate's question comes in. We call it unimodal. Unimodal speaks to there being one peak. Does that make sense what unimodal means? And we'll go into what the idea of mode means in a second. But unimodal means one peak. Uni meaning one, and modal meaning peak of area. You can have things that are like bimodal here. So this would be bimodal. Bi meaning 2 peaks. How's that sound right there, Pirate and DD? So unimodal means one peak. Uniform means one form. So uniform means it's one form, not a peaked area. So unimodal. Now this kind of goes with the idea of mode. Mode is most often. Modal is commonality or most common area. So a modal area, like to say unimodal, means there's like a common area of data. But mode in its literal sense means most often. So let's write question. What is the mode of this data? Yeah, you could be, well, we call it multimodal. So we don't say poly. You could probably say poly. I don't know. We'll probably say that. We say multimodal. If it has like a bunch of modes, multimodal. What is the mode of this data? Let's say here, data. And here's the data. Okay, what is the mode of this data? What is the mode of this data? What is the mode of this data? Mode. Oh, ignore me. Wait. Oh, that's not a mode. Go table. That should be a function. There's the most common is 1. Yeah, it's 1. Great job, Pirate. Yeah. So that's the mode, the most common. And if you look at the data, here's where we get into skew DD. So mode in its literal sense, Pirate, means most common. Does that make sense? So you can see there's we call this a modal area. So the idea of modal means like most common area, but mode means most often value in a data set. So the mode of this data, most common value is 1. And this is where we talk about skew. And so skew is the way the data is polled. And we have a saying in our class, right to the high, left to the low, whatever way the monster man's tail goes. So that saying is right to the high, left to the low, whatever way the monster man's tail goes. And this is Monster Man. There's Monster Man. So is Monster Man's tail going to the high or low side? So we say right to the high, left to the low. So right is the high side. Left is the low side. Well, be careful though. It's whatever way the Monster Man's tail... He's always looking back at his tail there. So right to the high, left to the low, whatever way the Monster Man's tail goes. Oh, I'm sorry, Pirate. We're here. Oh, ours? We have... Pirate, you're always welcome. And shouts... Teaching's tough. I've been doing this for 16 years, Pirate. We're all learning. All of us teachers are learning. Shouts to your teachers. Show them some love. And I promise they want you to learn, I bet. It's tough. And then I'm lucky with what I get to do, where I get to have some fun. They're very nice, and the technology I get to do this YouTube thing, Pirate, and I get to speak to people from all around the world. And I want people to learn. I love it when people learn stats. We're doing all the maths here, all the maths. Even with Skeletor, we're doing all the maths. Got Crash Bandicoot here doing all the maths. It's Wacky Wednesdays. Wherever I'm at, it's Wednesday. It's always Wednesday here. Wacky Wednesdays. It's actually Mega Mondays. We'll play that later. I only got 5 more minutes, and I got to run to an event. But so this is called positive skew sometimes. This is called negative skew. And what's really cool is usually you just visually find the skew. Does that make sense? Usually you just visualize the skew and find it. But in truth, we actually have functions for this. And you can literally just say skewness, and you can find out the data has a positive skew. So you can easily find out the skewness is positive. Now, if the data looks normal, what do you think the skewness of normal data would be close to? Oh, we haven't been getting stats in school for like 2 years. Oh, I'm sorry to hear that, Pirate. I always go for concepts. Like, what does this mean? Why are we learning this? What's the point of this? And then I'll talk about standard deviation next, because you asked about that. And then I'll even show you the formula. We'll talk about that a little bit. But like, what does it mean? Oh, you're talking about variance. Yeah, let's do standard deviation and variance next. So what do you think the skew value would be for normal data? What do you think the numeric value of skewness would be for normal data? What do you think if it's not skewed, the numeric value of skewness will be close to what? So what do you think the numeric value of skewness will be for normal data? And what does it mean to not really have skew? Skew is the way the data is polled. So when you see that data is skewed, you're going to see a tail in the distribution. This is right skewed data, and I always draw the monster man. because the way the data is pulled is the way it's skewed. So this would be right skewed positive data. You could say right positive skew, high skew, but it's the way the tail goes in the distribution. So we draw our monster man. But if the data looks normal, the skewness is close to 0. Also, think about our uniform data. Our uniform data doesn't have a tail, right? So the uniform data, remember the uniform data, the flat data? Its skewness is also going to be close to, you guessed it, 0. Actually, it's perfectly 0 because there's no tail to it. There's no monster man on this. But watch this, DD. You ready? Let's do data really skew. And once again, you don't need to know how to code. We're just showing an example. Peakish, then skewness. There is another term called kurtosis, which I don't know, we'll cover that right now. Random exponential. Times by -1. Okay, so what way is this data skewed? This is very extremely skewed data. This data is very, very skewed to the what? And then we're going to do standard deviation, and I got to run right after that. I'm going to immediately do that. Nice job, pirate! You get a puppet shark for that. That's a tiny puppet shark. Yeah, because look at this. We got Monster Man right here. And then Monster Man, there's the tail. Right to the high, left to the low, which is negative skew, whatever way the Monster Man's tail goes. So Monster Man, whatever way the Monster Man's tail goes, right to the high, left to the low, whatever way the Monster Man's tail, it's a rhyme. Right to the high, left to the low, whatever way the Monster Man's tail goes. And then you wouldn't need to do this, but you could always check it mathematically. There's a calculation, you see negative skew. But just memorization tools like that to remember. And then after a while, you just remember it's left skew. So standard deviation, Didi was talking about it a moment ago. If you look at the formula for standard deviation, I've only got I got 1 minute. Let me try. You ready? And feel free to come back for another office hours. Let me save this. Okay, we got it saved. When you look at how standard deviation is calculated, the formula kind of gives it away. It's the sum of the observations from the mean, actually, I guess sample mean, squared. The reason we square it is because some are below the mean, some are above the mean, and then you basically divide by sample size. So this right here is going to be variance. Oh yeah, we do a lot of office hours. You're free to swing by. We like positive people. We throw you some points right here. We always welcome positive people. So if you're here from any part of the world and positive, we like that. So this is variance. Variance is a measure of how far away observations are away from the mean, kind of on average. Now, we don't love variance because it's in squared units. So how do you fix variance? This is variance to make it non-squared units. So how would you fix variance to make it non-squared units? All you do is take variance and do that. And then you're left with standard deviation. And so standard deviation is in units of the problem, variance exactly under root. And so it's still like a typical distance something is away from the mean, because this part right here is how far are things away from the mean. We square it to make it all positive, because if you don't square it, you get 0. This will give a typical distance away from the mean, which is what a standard deviation is. And then you basically divide by this. It's a little bit of a fudge factor by doing n-1, because for smaller samples, it gets bigger. And there's a small change if you do... I'm mentioning too many topics. If you do this... What am I doing? That's not right. Now it is population standard deviation. Because now it's a slightly different bit of a formula. It assumes you have all the data, and you no longer do that n-1 fudge factor. It's population size -1. Well, Pirate and all his DD, good to see you. I've got to run to an event that starts in 9 minutes. Check out our cool outro right here. We have a lot of fun outros. So here we'll do a full outro. Oh, where's my outro? Closing. Bye for now, everyone. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.